Hey everyone, welcome back for another deep dive into the world of biochar. This week we're taking a look at the most read stories from Biochar Today.
And it's a really diverse mix this time. You've got everything from, well, battling forever chemicals.
Oh yeah, in Maine, right?
Yeah, Maine and Ghanaian coconut husks turning into some kind of like soil superheroes.
That's right. We're going to be looking at how biochar can be used for cleaning up waste and how it can help boost agriculture.
And even self-healing concrete.
Self-healing concrete. That sounds wild. All right, so let's kick things off with that first story up in Maine.
Yeah, so the issue is PFAS contamination in farmland.
And PFAS, just to remind everyone, that stands for per and polyfluoroalkyl substances.
Right. And these chemicals, they're linked to a lot of health problems, and they just don't break down in the environment. They're called forever chemicals for a reason.
Exactly, forever chemicals. So how does biochar even come into the picture here?
Well, in Maine, the PFAS contamination is largely due to past practices with sludge application. Basically, they were spreading sludge on the fields as fertilizer, but that sludge contained PFAS, and now it's stuck in the soil. But there are these two companies in Maine Standard Biocarbon and Clean Maine Carbon. They're producing biochar specifically to help with this problem.
So are they basically using biochar to suck up the PFAS from the soil?
That's the idea. They use a process called pyrolysis, which basically heats up organic matter in a low oxygen environment. Think of it like making charcoal. You're heating wood with very little oxygen. That's essentially what pyrolysis is.
Oh, okay, I get it. So it's like superheated charcoal, and that can trap those forever chemicals.
Exactly. The biochar acts like a sponge, and it can actually bind to those PFAS molecules, preventing them from moving around in the soil and contaminating crops.
That's amazing. So how much biochar are these companies actually producing?
Standard biocarbon is cranking out about 50 cubic yards a day, which is pretty impressive. And Clean Maine Carbon, they're producing around 20 cubic yards.
Wow, so they're really scaling up. But I imagine there are still some challenges to implementing this solution on a larger scale, right?
Right. First of all, more research is needed to see just how effective biochar is at containing PFAS in the long run. We need to understand how long it lasts and how it impacts the overall soil health.
And I bet the cost is a factor too.
Yeah, for sure. Production costs for biochar can be high. Plus, there aren't enough incentives for farmers to make the switch right now.
Even though there's that USDA subsidy program.
Yeah, but the subsidies aren't quite enough to make biochar a no-brainer for most farmers. We've still got to work on making it more cost-effective.
It definitely sounds promising, though. All right, let's move on from soil remediation to something that sounds a little bit more exciting. What's this about turning trash into fuel?
Ah, yes. This is where things get really interesting. We're talking about copyrolysis here.
Copyrolysis. So that's like pyrolysis, but with an extra ingredient.
Exactly. Instead of just biomass, you're adding something else to the mix, in this case, plastic waste. One recent study used oil palm empty fruit bunch biochar, or EFB, and high-density polyethylene. That's the stuff milk jugs are made of, HDPE.
So they're basically mixing agricultural waste with plastic waste.
Yep. And they put it through the copyrolysis process, and what they found was pretty amazing.
What happened? Did they actually manage to make fuel?
They did. They figured out that a specific ratio of EFB to HDPE, 55.45 to be exact, gave them the most bio-oil. And this bio-oil had great properties like high energy density and low viscosity. That means it can actually be used as fuel.
Wow, that's incredible. So we could actually solve two problems at once, plastic pollution and reliance on fossil fuels.
Potentially. It's still early stages, but it's a very promising technology.
I mean, there's got to be some downsides, right?
Well, there are still challenges. For example, they need to figure out how to manage the acidic byproducts that are formed during the copyrolysis process.
Ah, right. It's never quite as simple as it seems, but overall it sounds like a really promising development. Now, let's talk about waste management. I know it's not as exciting as turning plastic into fuel, but it's definitely important.
Right, it's crucial. And biochar can play a role here too. One of the biggest challenges with waste management is dealing with heavy metals.
Right, because things like sewage sludge and municipal waste can be contaminated with heavy metals, which is a huge problem.
Exactly. But what if we could use copyrolysis to turn that waste into biochar and in the process actually reduce the concentration of heavy metals?
Oh, that's interesting. So instead of just trapping the heavy metals, you're actually reducing their presence.
Exactly. That's what researchers are finding. One study showed that blending sewage sludge with municipal waste during copyrolysis can actually lead to lower levels of heavy metals in the resulting biochar.
That's pretty impressive. What kind of heavy metals are we talking about here?
We're talking about things like selenium, mercury, and cadmium, some of the most dangerous heavy metals out there. And the researchers found that a 50% blend of municipal waste was the most effective at immobilizing those heavy metals, which makes the biochar much safer for use in agriculture.
That's incredible. Turning something that's normally considered hazardous waste into a valuable resource, that's amazing. Now, biochar's uses go way beyond just cleaning up waste, right? I mean, I've heard about self-healing concrete. That sounds almost like science fiction.
It does sound futuristic, doesn't it? But this is real science, and it's pretty amazing. Researchers have figured out how to use biochar to create self-healing concrete, and it all comes down to bacteria.
Wait, bacteria in concrete? How does that even work?
So they take coconut shell biochar and use it as a carrier for bacterial spores. These spores are basically dormant bacteria just waiting to be activated. They embed these biochar capsules into the concrete.
Okay, so you've got tiny capsules of bacteria hiding inside the concrete. Then what?
When a crack forms in the concrete and water seeps in, it activates the bacterial spores. And guess what? These bacteria, specifically Bacillus species, can produce calcium carbonate, which is a key component of concrete.
So the bacteria actually start repairing the crack from the inside out. That's so cool.
It is pretty amazing. The coconut shell biochar is really important here because it provides a stable environment for the bacterial spores, allowing them to survive for a long time. Plus, it helps strengthen the concrete overall.
So it's like when you get stronger concrete and it can heal itself. Did they actually test this out? Like, how well does it actually work?
Oh yeah, they did experiments. They found that coconut shell biochar combined with a specific type of bacteria called Bacillus cereus was able to heal cracks up to 0.888 millimeters wide. That's almost as thick as a credit card. And they were able to do this within 56 days.
Wow. That's incredible. Think about all the implications for construction. Less maintenance, longer-lasting structures, and we'd use fewer resources overall. Now we've got to take a quick break, but we've got more incredible biochar breakthroughs to discuss when we come back.
Stick around, folks. There's a lot more to come. All right, welcome back to This Week in Biochar. Now we're going to explore how biochar can actually give recycled concrete a boost.
So we're talking about recycled concrete aggregate. That's just crushed up old concrete, right? Seems pretty straightforward.
Yeah, the concept is simple, but there's a catch. Sometimes that recycled concrete, or RCA as it's called, still has some stuff left over from the original concrete.
Leftovers, like what? Like bits of rebar and stuff?
Well, not exactly the rebar itself, but iron residues. You know, when the rebar corrodes, it leaves behind these residues that can actually mess with the strength and durability of the recycled concrete.
So it's like you're building on a foundation that's not quite solid.
Pretty much. But guess what? Researchers are looking into ways to use, you guessed it, biochar to tackle this issue.
Wait, really? So coconut shell biochar makes a comeback here?
You know it. This study focused on using coconut shell biochar to deal with those iron residues in the RCA. And the results? Very promising, I'd say.
Okay, I'm hooked. Tell me more. How does biochar even help with this?
It's kind of like a two-in-one solution, actually. First, the biochar acts like a magnet, attracting and binding to those iron particles, removing them from the RCA.
So it's like cleaning up the RCA, making it purer.
Exactly. And second, those tiny biochar particles, they can actually slip into all those cracks and pores within the cement, almost like tiny little fillers, making the whole structure stronger.
So it's cleaning up the bad stuff, A and D, making the recycled concrete stronger. Talk about a multitasker.
Right. I mean, if we can figure out how to efficiently remove those iron residues and boost the performance of recycled concrete, that would be huge for making construction more sustainable.
It all comes back to using less virgin materials, right?
Absolutely. Biochar could be a key player in unlocking the full potential of recycled materials in construction.
Okay, on to our next story from biochar today, and this one focuses on sweet potatoes.
Sweet potatoes. This is a really fascinating study that delves into the effects of biochar on sweet potato yield, looking at how biochar affects the plant itself. They were using a technique called short-term biochar application, or STBA.
Short-term biochar application. So instead of mixing the biochar into the soil years in advance, are they applying it closer to planting time?
Exactly. It's about getting those immediate benefits of biochar. And they experimented with different doses too, seeing how various amounts affected the growth of the sweet potatoes. But that's not all. They also looked at the plant's genetic response to the biochar.
Genetic response. We're talking more than just bigger potatoes. They were looking at how biochar affects the plants on a deeper level.
Right. They used a technique called RNA sequencing. which lets scientists see which genes are turned on or off, in response to different things. In this case, they were trying to figure out how sweet potato genes reacted to biochar.
It's like they were looking inside the plant's control center, seeing how biochar was changing things. So did they find anything? Did the biochar actually help those sweet potatoes grow?
Oh, yeah, the results were impressive. The study showed that using biochar increased the sweet potato yield by up to 72.2%. And get this, it didn't affect the quality of the starch, which is really important for sweet potatoes.
Wow, that's a huge increase. So how does biochar work its magic on soil and plants? Like what's going on beneath the surface?
Well, think of biochar as a superhero for your soil. First off, it's like a slow-release fertilizer. It holds on to important nutrients like nitrogen and potassium and slowly releases them to the plants over time.
So it's providing a constant supply of nutrients to the plants.
Exactly. Plus, biochar can raise the pH of acidic soils, making them more suitable for plants to thrive. And it improves the soil structure overall, which means better drainage and aeration and happy roots.
It's creating a healthy environment for the plants to thrive. What about that genetic response, though? What did the RNA sequencing show?
That's where things get really interesting. The RNA sequencing revealed that biochar actually influenced genes that are involved in starch and sucrose metabolism. Basically, these are the processes that control how plants create and store energy.
Ah, so it's affecting how the plants utilize and manage their energy resources.
Yes, and they also saw changes in hormone pathways, suggesting that biochar might actually play a role in regulating plant growth and development in general.
Amazing. Who knew that adding biochar to the soil could have such a big impact on what's happening inside the plant?
It really highlights how closely connected soil health and plant health are, and how biochar can have a positive impact on both.
So by understanding these connections, scientists can develop even better ways to use biochar to improve agriculture and make sure we have enough food in the future.
Exactly, especially as we face challenges like climate change. Now, even though we've been talking about all these amazing benefits of biochar, there's always room for improvement.
Right. Like with anything, there are always challenges to overcome.
Yeah, and one thing we need to keep in mind is that we need to make sure the production of biochar is as sustainable and environmentally friendly as possible.
That's a great point. If we're touting biochar as a green solution, we need to make sure the way we produce it is clean too, right?
Absolutely. And one concern with biochar production is that sometimes harmful organic compounds can be created during the pyrolysis process. We're talking about things like benzene, hexane, and toluene. Not good.
Oh, wow. Those are some serious contaminants. But luckily, some people are working on this, right?
Yes. A research team at Penn State is tackling this issue head-on. They got a grant from the USDA to figure out how to make biochar production cleaner and safer.
So they're basically trying to develop a recipe for clean biochar, so to speak.
That's a good way to put it. They're experimenting with all sorts of different biomass feedstocks, from farm waste and algae to even municipal waste, to understand how these different materials affect contaminant formation.
And hopefully, they can find ways to prevent those contaminants from forming in the first place.
That's the goal. They want to create optimized production strategies for those big biorefineries, the places that turn biomass into all sorts of different products, including biochar.
It's great to know that folks are working on this. It's so important to make sure that every step of the process, from start to finish, is as sustainable as possible.
I completely agree. Okay, so for our next story, we're shifting gears a bit and taking a trip to Ghana. There's a really inspiring project happening there that's using biochar to make a real difference.
Oh, I'm all ears. What's going on with biochar in Ghana?
Well, there's this company called True Cocoa Ghana, and they're working with an organization called Growth Investment Partners Ghana, or GIP Ghana, to turn coconut husks, those things that are often just thrown away, they're turning them into biochar.
So they're tackling waste A&D, improving soil health. Double win. And I heard there's a social impact angle to this project as well.
Yes. This project is directly supporting over 4,000 smallholder farmers. Instead of just discarding those coconut husks, they can now sell them for biochar production, which gives them extra income. Plus, they're also getting training on biochar and sustainable agriculture.
Wow, it's incredible how something like biochar can have such a positive ripple effect. So we've got the social impact, the waste reduction. What about the environmental benefits of coconut husk biochar specifically? Is it any different from other types of biochar?
Coconut husk biochar provides all the same great benefits as other types of biochar. It helps sequester carbon in the soil, improves water retention, makes nutrients more available to plants, and ultimately helps boost those crop yields for the farmers.
So it's creating a more sustainable agricultural system and supporting the local community at the same time. What's not to love about that?
Right. And there's one more thing. True Cocoa Ghana is also working with an organization called PRO.Earth, which is a carbon removal credit certifier.
Oh, that's interesting. So they're really making sure this project has a measurable and verifiable impact on the environment.
Exactly. It really shows their commitment to making this a truly sustainable and impactful initiative. They're not just talking the talk, they're walking the walk.
That's fantastic. All right, for our last story on This Week in Biochar, let's bring things a little closer to home. This one is about turning grass clippings into biochar.
Ah, yes. The humble grass clipping. Turns out those little bits of green can be transformed into a valuable resource.
I have to admit, I usually just bag up my grass clippings and toss them in the yard waste bin. Is there really that much potential there?
You might be surprised. This study focused specifically on St. Augustine grass, which is a type of grass that's really common in arid regions. They wanted to see if they could use a local resource to create a sustainable solution.
So they took those grass clippings and made biochar. What did they find out?
They discovered that biochar made from those grass clippings was a great source of nutrients, particularly potassium and phosphorus. They even tested it out in a drip irrigation system, and the results were pretty impressive.
Okay, so we've got drip irrigation, which, just to remind everyone, delivers water directly to the roots of plants, and now we're adding grass clipping biochar to the mix. What happened?
Adding the biochar to the drip irrigation system made a huge difference in nutrient retention. It reduced nutrient leaching, which means that the nutrients stayed in the soil where they belonged instead of being washed away.
That's crucial, especially in arid regions where water and nutrients are so precious. You don't want any of that good stuff going to waste.
Exactly. It all comes down to using resources more efficiently, and this study showed that grass clipping biochar can be a valuable tool for doing just that.
Wow. We have covered a lot of ground today, from cleaning up forever chemicals to creating fuel from trash and empowering farmers in Ghana. I'm constantly amazed by all the different ways biochar is being used to tackle environmental challenges.
What's really exciting to me is that we're just starting to scratch the surface of biochar's potential. Every week, there seems to be a new discovery or application that pushes the boundaries of what we thought was possible.
It makes you wonder what the future holds for biochar. What stood out to you the most out of all these stories? It's tough to pick just one. There were so many cool stories. But I think that one about the coconut husk biochar in Ghana, that one really stuck with me.
Yeah, it's a really powerful example of how sustainability can be about so much more than just the environment. It can be about lifting up communities and creating opportunities.
For sure. Sometimes it's easy to get caught up in the technology and forget about the people involved.
Right. And this project, it really shows how biochar can be this catalyst for positive change, not just for the environment, but for people's lives too.
Absolutely. But stepping back for a second, thinking bigger picture, all these different biochar applications we've been talking about, they kind of point to a bigger shift in how we think about things, don't they?
Yeah, I think so too. It's like we're moving towards this more circular way of doing things, more regenerative.
Exactly. Like instead of just trying to solve problems one at a time, it's about changing our whole mindset, how we view waste and how we manage resources.
It's about recognizing that what we often consider waste, it can actually be a valuable resource.
Yeah.
And biochar, it really embodies that idea. I mean, you can make it from all sorts of things that we would normally just throw away.
Right. And it's like creating these closed loop systems.
Yeah.
Mimicking how nature works,
Totally. Instead of that old take, make, dispose model, it's about reusing and regenerating resources.
And biochar, it's such a versatile material that it can play a role in so many different aspects of that transition.
It really feels like biochar is this symbol of possibility.
Mm.
It shows us that there are innovative solutions out there, often in the most unexpected places.
It makes following these developments so exciting. There's always something new and amazing happening in the world of biochar.
Exactly. And that's kind of what I want to leave our listeners with today, a sense of curiosity. When you're going about your day, just take a look around and ask yourself, where else could biochar make a difference? What problems could it help solve?
That's a great challenge for our listeners. You never know, someone listening right now might be inspired to come up with the next big biochar innovation.
I wouldn't be surprised. The future of biochar is so bright, and it's up to all of us to explore what's possible.
Couldn't have said it better myself. Well, that's it for another exciting episode of This Week in Biochar. We covered a lot today, from tackling those forever chemicals to empowering farmers and building self-healing concrete.
It's amazing to see the impact biochar is having around the world.
Until next week, keep those biochar fires burning.